We learned about line angle structures in Chapter 8, so let's review just a little bit. Remember, these are structures that show just the framework of the molecule. We locate the positions of the carbon, and hydrogen is not written, it is assumed, because we know that carbon has 4 bonds. So any bonds that are not drawn are assumed to be hydrogen. The carbon is found at the peaks and the valleys of the lines that are drawn. And if we have a branched molecule, those branches come off of the peaks or the valleys. When we draw double bonds, we can show that it is cis or trans, depending on where the carbons are located on either side of our bond. So if it is cis, the carbons are on the same side of the double bond. If it is trans, the carbons are on opposite sides of the double bond. And our triple bonds, we try to represent the shape of the molecule by drawing a linear 180-degree bonds around our triple bond. So we try to make it straight when drawing the triple bonds. The triple bond is represented by the 3 lines between 2 carbons. We can also draw line angle structures with heteroatoms, but there is one small difference. When we're drawing for heteroatoms, and when I say heteroatoms, I mean different than carbon or hydrogen, we do have to draw the bond to the oxygen or nitrogen, which are the most common elements that are included. We also have to show the hydrogens that are attached to any of the other elements. So example that we're given here, we have 2 carbons, so this is ethanol. So our first carbon would be here, the second carbon. We do have to draw the bond between the carbon and the oxygen. And we also have to draw the bond between the oxygen and the hydrogen. And this is because we can't just assume them, so we do have to draw them. So here's a practice for you to see if you understand this concept. Pause the video and determine the formula for each structure. If we look at our first structure, we have 1 carbon, 2 carbons, 3, 4, 5, 6, 7. So this would be 7 carbons. We would have to count our hydrogen, 1, 2, 3, 4, 5, 6, 7. Here, number 4 has 4 bonds, so there would be no hydrogen there. 8, 9, 10. Number 5 has 3 bonds, so that would be 11, 12, 13, 14. There's none drawn on the oxygen, so there would be no hydrogen coming off of there. So C7, H14, and we do have 1 oxygen. The oxygen always gets written last, so it's always carbon, then hydrogen, and then any other element. We look at our next example. We have 1, 2, 3, 4, 5 carbons, 6 at the end of the triple bond. So because no element is written there, that is a carbon. So C6. Now we have to count our hydrogens. 1, 2, 3, 4, 5. We've got 3 bonds off of that third carbon, so it needs 1 more. 6, 7, 8, 9, 10, 11. If we look at that carbon, it's already got 4 bonds, so we can't have any more. So we would have H11, and then we have 1 nitrogen in the formula. Our last example, we have 1, 2, 3, 4, 5 carbons. Because there's nothing, no other element drawn off of that oxygen, that is another carbon at the end of the bond. So we count our hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Our 2 has 3 bonds, so 12. So these would be the formulas for these particular line angle structures.